Hello everyone, today let's take a look at another integer partitions question, quantipus number 82, asking us in how many ways 13 identical objects can be divided into 3 unlabeled groups so that every group contains at least 2 objects and no group contains exactly 6 objects. And the reason I added a bunch of random constraints was just to show that no matter how many constraints we add to an integer partitions question, it's still going to be pretty easy to solve. That's just because when we solve integer partition questions without constraints, we're going to have to list out every single outcome anyway, so just adding some constraints will not be a problem. So every group's going to have at least 2 objects, so let's just give all of our groups 2 objects just for starters. Now that we've given 2 to each of our groups, how many have we given out in total? Well, 2, 4, 6, right? We've given out 6 total. We had 13 to give out, so we need to give out 7 more. So to solve this, we can just find the number of partitions for 7 and then add them back on to satisfy the constraint that every group must have at least 2, right? So for instance, I could partition 7 into 7, 0, 0, and then that would correspond to, when we add it back, 9, 2, 2. So let's just count the number of partitions of 7 into 3 groups first. Now again, for the sake of future problems that we're going to do, even though it doesn't matter now, it's going to be helpful to think about this in terms of subgroups based on the number of groups that are empty. So let's start off where we have 2 groups empty, and in that case we only have 1 partition. It's going to be 7, 0, 0. Now let's move on to the case where we have 1 group empty. So if I have 1 group empty, then I could do 6, 1, 5, 2, 0, 4, 3, 0, and that's it. Now if I go down and I do 0 groups empty down here, well, I could get 5, 1, 1, I could get 4, 2, 1, I could get 3, 3, 1, or I could get 3, 2, 2. So these right here are the total ways to partition 7 into 3 groups. Now let's add them back onto our originals because we gave 2 to each group to start, right? So let's do it for this one. We already did it here. This is going to be 8, 3, 2. So I've gone ahead here and just worked them all out. It's pretty simple to do, but now you can see that everything in here is going to add up to 13 and everything is going to have at least 2, which is exactly what we want, but we have one more constraint and it's that no group contains exactly 6 objects. Okay, so how easy is this constraint? We just go down and we look at the groups that have 6 objects in them. Okay, this one has 6 objects, you're gone, this one has 6 objects. So now that we've satisfied all of our constraints, all that remains is we just count them up. 1, 2, 3, 4, 5, 6. We have 6 that satisfy all these constraints. So that's all it is to solve this problem. Just list out every combination and cross off the ones that don't meet your constraints. And it's counterintuitive, but that is the best you can do for identical objects into identical groups.